Alright, in this video we're going to start our next unit, which is on solving equations and equivalent equations. So the first thing we're going to take a look at is just taking a look at equations and how we make them equivalent to each other. So in your notes, let's make sure we title today's notes. This is day 1. We're going to do equivalent equations. And then make sure you put today's date in the top corner of your notes. The first thing we're going to actually do is take a look at that word equivalent and just make sure that we're all on the same page with what equivalent means. So if I told you that something was equivalent, what I'm saying is that something is the same. So equivalent is just a synonym for the word same. So things that are equivalent would be like decimals. And if you try to find the equivalent version of a decimal, you look at a fraction. Or if you look at equivalent fractions, for example, like 1/2 is equivalent to 2/4, is equivalent to 3/6, because they're all equal to 1/2. So the equivalent just means the same or equal in value. So when we're looking at equations, to keep something equivalent means you have to keep it the same on both sides of the equation. A lot of times when you're working with equations, the idea of a balance comes into play. So remember, a balance is just where you have something equal to something on each side. So let's take a look at an example. Of an equivalent equation and how we keep the equation equivalent. So let's say you're given the following equation. 4x plus 8 equals 2x minus 12. Make sure you give yourself space as we're writing our notes, because we're going to be doing things on the left-hand side of your paper, and then notice them on the right-hand side. So to keep an equation equivalent, if we follow these steps, our first step is we're going to add 10 to each side of the equation. So I'm going to show that I'm adding 10 to each side of the equation. So now think about like terms. If I was going to add 10, I couldn't add 10 to 4x because it has an x. So I would have to add the 10 to the 8. And then same thing on the other side of the equation. I can't add 10 to 2x because it has an x, so I would add it to the negative 12. When we say two sides of the equation, we're saying what's on one side on the left-hand side of the equal sign and what's on the right-hand side of the equal sign. So here we added 10 to both sides of the equation. All right, so doing that, my 4x doesn't change. So I get 4x plus 18 equals 2x minus 2. I've just created an equivalent equation by adding 10 to both sides of the equal sign. Let's do another step and find a way to make another equivalent equation. We're going to add x to each side. Alright, same idea. When we're adding x, we're going to add it with a like terms. So this is why we spent that first couple weeks just reviewing combining like terms and simplifying. So adding x to both sides of my equal sign would mean I have to add x to the x values. So 4x plus 1x is 5x's plus 18, because that doesn't change, equals 3x minus 2. So again, I've just created another equivalent equation by following that second step. All right, our next step will be to subtract 3x from each side. So again, we're going to make sure we do the like terms, so I can only subtract x's from other x values. So I'm going to line it up with my x values that I currently have. So subtracting 3x on both sides. This gives me 2x plus 18 on the left-hand side equals negative 2. Because in this case, the 3x's reduce or cancel and go away. So again, we've just created another equivalent equation by following these steps. Something that is the same. Our last step will be with subtraction again. And we're going to subtract 5 from each side. So for this one, again, I find my like terms and subtract 5 on each side. So I have 2x plus 13 equals negative 7. So for these problems, we're not necessarily trying to solve. We're just looking to create different versions by making equivalent equations. All right, let's look at our next example. Example 2. This time we're going to write the steps to form each equivalent equation. So last time we followed the steps, this time we're going to write the steps. So again, you're going to want to give yourself space on the left-hand side of your notes and the right-hand side. We're going to make a little table. So we're given, this is the equation that we're given. 7x minus 3 equals 2x minus 1. All right. So the question is asking us, how do I go from this equation to this equivalent version of it So what's the step to go from our given spot to this spot right here? So when you're looking at addition and subtraction, you're essentially just looking at what values changed. So the negative 3 stayed the same. That hasn't changed. The negative 1 also stayed the same. So that means that I didn't add or subtract anything to the constant values here. However, the x values changed. If you look at 7x, it reduced to 6x, and 2x went down to 1x. So what it looks like, what happened here, is that it looks like I subtracted 1x from both sides of the equation. So my step would be subtract x from both sides. That's how I got from the given to my step 1 here. All right, for step 2, now we're going from what we had in step 1 to the next part. And again, it's asking you, how did I get from this step to the next step? So we look at, for adding and subtracting, what has changed. The 6x and the x did not change, so I didn't do anything with the x values. However, the -3 turned into 2, and the -1 turned into 4. So I have to ask myself, how am I getting from -3 to 2? Whatever that value is has to be the same over here. So from -3 to 2, that means I'm increasing, so I'd be adding, because I'm going from a negative value to a positive value. And to get from -3 to 2, I would have to have had 5 be added to both sides. So here we're adding 5 to both sides. So now instead of the example 1 where we were doing the step, here we're trying to figure out the step. All right, our next step, we're going to go from 6x plus 2 equals x plus 4 to 6x plus 12 equals x plus 14. So again, we're trying to figure out what changed from step 2 to step 3 to keep it equivalent. So here, the 6x stayed the same and the x stayed the same, so it looks like I'm adding something to my constant values again, and I think I'm adding 10, because 12 plus 2 is 12, 2 plus 10 is 12, and 4 plus 10 is 14. So my step for number 3 is that I've added 10 to both sides. Okay, we have 2 more steps. For step 4, I've got 5x plus 12 equals 14. So again, we look at what changed from my step 3 down to step 4. This time it looks like an x completely went away, so it means that I am subtracting here. So I had to have subtracted x from both sides. And our last step, just to create an equivalent equation here. Again, you look at what changed. So now the 12 is gone, and the 14 turned into a 2. So my guess is that I have subtracted 12 from both sides. Okay, so that's creating equivalent equations using addition and subtraction. We're going to move into multiplication and division later, but for now you can start your homework. It's the first 5 questions for Unit 2 on today's date. Okay, so make sure you title that in your notes and get started on those questions.